Good morning. We're going to do section 5.2 real quick over solving systems with substitution. So here we go. All right, so here are the directions for substitution. If you would like to press pause and write them down, I know some of you like to write directions down so that you have them for later. All right, so it says number one, substitution step, solve one equation for x or y, whichever is easier, x or y. And then we're going to plug it or substitute it, which is why it's called substitution. Oh, let's spell it correctly. An E here. Substitute it into the other equation. And then blank the value of y for x or y into either equation to get the other value. So we will plug the answer that we came up with here into the other equation and come up with the x or the y that we didn't have. And the answer is an ordered pair because remember, the answer represents where the two lines cross, just like when we did graphing. All right, so here's our first example. So the first example or the first set of directions said, number one, make sure one is solved for a particular letter. And you can see that y is the one that is solved for right here. So what we're going to do is we're going to take, in this second equation, we're going to take out the y, and in its place, we are going to put the 5x. So negative 2x plus 5x equals 3. And now we're just going to use our solving skills from chapter 1. So here I would combine like terms and divide by 3. So x is 1. So that means I have part of the answer. Remember when we write an ordered pair, it's x comma y, and this is my x, so it goes in the first position. And then to get the y, I take the answer and I plug it back in. And I always put it back in the box that I came up with at the beginning. So y equals 5 times 1, so y is 5. So my answer is 1, 5. And again, that is the point where those two lines cross. So let's try this one. So number 2. So are any of the letters already isolated? Well, you can see that x is isolated right here. It's by itself. So, and it equals this right here, 1/2 y plus 3. So in the other equation, I go find the x, and I'm going to cross out the x, and in its place, I'm going to put this box. So 2 times 1/2 y plus 3 minus y equals 6. Okay, so all I did there was take out the x and put the box in, and then I just dropped this, this, and this. They just dropped straight down. Now I'm going to distribute. So this is 1y plus 6 minus y equals 6. So 1y minus 1y, they would cancel. It's 0y. So then I have 6 equals 6, which all the y's are gone. So since this is a true statement, 6 does equal 6. This is infinitely many solutions. So that means that those two lines are actually the same line written in different forms. Okay, so if I graphed it, they would graph the same. So since they're the same line, they share all the points, which is why it's infinitely many. Let's try number 3. So you can see here that the y is alone. So we're going to take this whole piece right here, this negative 4x plus 11, and we're going to plug this in for y in the other equation. So I look up here, here's the y. So I'm taking that and putting it in there next to the 2. So the 8x will drop, the plus 2 drops, and then in the parenthesis, I put the negative 4x plus 11, and then I drop that equals 13. Okay, so I'm going to distribute. So 8x minus 8x plus 11 equals 13. So you can see these two cancel because they're like, so I have to combine them. That's 0x, so that's 11 equals 13. That's not true. 11, actually that should be 22. Sorry, that's my fault. I need to distribute the 2. So those don't equal each other. So this answer is no solution. And what no solution means is that these two lines are parallel. They have the same slope. They never cross. And since the answer is the solution is where the two lines cross, they don't ever cross because they're parallel, the answer is no solution. All right, I want you to press pause and try number 4, and then I'll do it too, and we'll see if we get the same answer. Remember, your answer is an ordered pair, x comma y. It's where these two lines cross. Okay, so on number 4, you had a choice. Okay, you could either plug this in here or this in here. Okay, so I'll just do the top one. So x is already solved, so I'm going to take this. And in the other equation, I'm going to find the x. And in its place, I'm going to put that box. So 4y plus 5 equals 3y minus 2. So I'm going to subtract 3y on both sides. And then I'm going to subtract 5 on both sides. So y is negative 7. And then to get my x, I take the negative 7 and I put it back in. And I usually almost always put it back in the box that I created. So x equals 4 times negative 7 plus 5. And you can stick this right into Desmos. That's negative 28 plus 5, or negative 23. So my answer there is negative 23, comma, negative 7. And again, that represents where the two lines cross. Okay, let's try this one. So we've got x. Actually, press pause and give that a try. See if you get it. Okay, so we've got this x solved. And we want to put this in for x in the other equation. So we're going to take this x out and put this box in there. So 3 times 3y plus 1 minus 5y equals 11. So we're going to distribute. So 9y plus 3 minus 5y equals 11. So that's 4y when I combine like terms, the two y's. I drop the plus 3 and the 11, and then I subtract 3, which is 8, and divide 8. So y is 1. So I have half the answer, and then I take that 1 and I plug it back into the box that I came up with to begin with. So x equals 3 times 1 plus 1. Well, 3 times 1 is 3, plus 1 is 4. So my solution here is 4, 1. Now, remember, I could graph these as well as do substitution, and I would get the same answer. Okay, I would have to put them both in slope-intercept form, but I would get the same answer. It doesn't matter how you solve it, whether you use graphing or substitution, or and there's another method called elimination. It doesn't matter how you do that as long as you solve the equation correctly. All right, let's go ahead and do this story problem, and then we'll be done. It says a snack bar sells 2 sizes of snack packs. The large snack pack is $5, and the small snack pack is $3. In one day, the snack bar sold 60 snack packs, and for a total of $220. All right, so if I write a system of equations, I look at the labels to tell me what to do. What I notice about these labels is that 3 of them are money. Do you notice that? All 3 are money. So those are going to be in one equation. So one of the equations is going to be about money. So we'll do 5x. There's $5 for large snack packs, and 3y. So $3 for small snack packs, and it equals $220. Okay, the only other number I have that I haven't used is the 60 right here. So I know that's going to be a total because that says that's how many they sold in the day. So I know from this equation, that x is large snack packs and y is small. Okay, and I know that because of up here, the large were $5 and the small were $3. So I know we sold some large, so that's x, and some small, so that's y. Okay, so now I have my equation set up. I can use substitution to solve. So since I have my equations now, let's see, do we want to solve for x or y? It doesn't really matter. Let's just solve for x. So we are going to make a t and subtract y on both sides. So x equals 60 minus y. Okay, so there's my equation that's solved for. So in the other equation, which is the 5x plus 3y, we're going to take our 60 minus y and put it in for x right there. So we're going to cross out this x and put it in. All right, so that's 5 times 60 minus y plus 3y equals 220. My picture's in the way. Let's move that up. Okay, so let's see. That would be 300 minus 5y plus 3y equals 220. And if I combine these two, that would be negative 2y. And then I would subtract 300 from both sides. And that gives me negative 2y equals negative 80. And then if I divide by negative 2, there are 40 of whichever y is. So let's see what it was. Y is the small. So if I use my original, or I can use this one here, and I take the 40 and I put it back in there for y, let's change colors. So this would be x equals 60 minus 40. So x is 20. So it looks like they sold 20 large and 40 small. And I figured that out by writing the equations and then using substitution. And honestly, I would probably use elimination on this one once we learn that. But that's the way you do substitution on that one. All right, so we're all done. So we're going to go ahead and do our assignment now. So 5.2, thanks.